advanced, and then MATLAB will create some warnings, but the good thing is that it generates this uh, 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 RLC codegen underscore win64.thunk.pc win64.dll, which we're going to use later on. We're also going to use specific components wherein I have these components that we need to include to our GUI or to our applications application program later on. So I already have made a very simple. Let's say I'm going to make by the way, so we need first to test if our library is running okay. So we need then to go to the script environment, to the ERT shared library underscore run.m, and this is where we try to use the function load library rather than using the sim command and open model and so on and so forth. So now the model is now a DLL file. So once we have this one, I'm just going to run through with the initialization. I'm going to put some CLC here so that we can see the screen correctly. And then I'm going to load library. So the library file is actually, let me just run through this one. Library file is your RLC underscore codegen underscore win64.dll, and the header file is actually this mheader.m. So now it's being loaded, and then there's some things that you need to understand is that the library has some library functions, and these are the things that you need to call through throughout the figure or throughout the MATLAB script or MATLAB function that you want to incorporate to your GUI. So take note on these things. Lib.pointer RLC codegen underscore u is the inputs. Lib.pointer RLC codegen underscore y are the outputs. These are the things that you need to call every time step. So first is we need to initialize the model. We need to get the output of the model. If ever we need to terminate, we need to call this one. And then every time that we move to another time step, we're going to use this codegen underscore update, right? So the script would actually just do a vectorization of the things that he needs. So this is one thing that he did here, wherein, okay, I'm going to do a simulation of 0 to 10 seconds with a DT of what was used in our model. So I just take into account that I have two outputs. The time would be a number of steps, right? And then the outputs would be a vector. So it's just vectorizing that values here. And then we're going to initialize the model first. So this is what it's going to do. So this is now the part wherein it's going to run through the whole process, the whole 0 to 1 second. And the thing here that we need to understand is that this input, right, you can see u.value.input is equivalent to a certain value. So in my case, to make it really faster to do this demo or to do this video, instead of incorporating some Excel files or any other files that I want to actuate the input signal to my model, I just use the step time value that counts accordingly. And then we need to get the we need to use the time step execution, right? So you can see here that once we call this one, it will run through one cycle and then wait for the next time step. So the next one would be we need to get the output of the model. So to get the output is that first we need to define y is equivalent to call live, then model name underscore y, and then we're just going to extract the different values. So one thing that we would the one thing that you would notice is that if it let me just run through this one. I have this one already, right? Okay. So these are the things that you need. Let me just copy this one. And once I define this one, u dot, then I press tab, then I can get the value. Then I press another period, then press tab, then that's my input, right? So it gives me the output. If I do something instead of u, I'm going to change it to p, or y, sorry. P should be for parameters. I'm going to change it to y, so this can be any variable. Then I can say y dot value. Then I would have my output ports, which is labeled as current and voltage. So once I have this one, it just runs through the whole process of the simulation. Then the next one is I'm just going to update the states. And pretty much, let me just run through this one. Right, so it's like I'm already pressing the play button. It's going to simulate, I think, a lot of data, since my time step is like e to the power negative 5, 1 times 10 to the power negative 5. That would be like 10,000, 10 million, 10 million or something like 100. Let's wait for it to finish the simulation.